Good afternoon and welcome to the webinar module 2 of the RICCAR webinar series on climate change analysis using GIS tools. My name is Marlene Tomaskevich and I serve as Regional Advisor for GIS for climate change analysis here at ESCWA. Before we get started, let me go over some logistics. The webinar webpage provides PowerPoint handouts in both English and Arabic, as well as exercise data sets for this module, including this one, and a link to the live event. Following our recordings for each session. If you did not have the opportunity to join us last week, I encourage you to do so to review webinar module number 1. It will provide some good overview of RICCAR, as well as the climate change outputs that were presented in our reports. We have over 400 registered participants for this webinar series, and as a matter of fact, over an hour ago, we noticed there was 508 registrants for today. Because of this, we are only broadcasting the webinars as live events, and again, available via demand. I apologize that it is not as interactive as it could possibly be by allowing you to chat in, but you can post questions via the Q&A chat. This questions will be moderated by Joella Mayer, and she'll be responding to your questions via the chat. And as time allows, we will answer questions live at the conclusion of the presentation. You may submit your questions in English, Arabic, or French, as you feel comfortable. And otherwise, we are happy to follow up with you via email following the sessions. So let's get started. Again, this is a series entailing 6 webinars, so 6 webinar modules. This is the second module of 6. Today we'll be going over viewing NetCDF files and regional climate modeling datasets using GIS. The objectives of this module cover what are NetCDF files, for those who are not familiar. We'll be utilizing the Multidimension tools, which is a method to work with NetCDF files in a GIS platform, and we'll be visualizing NetCDF files. For the GIS portion, we'll be using ArcMap GIS. We assume that you have some foundation of GIS, but those of you who do not worry. We can assist you. There are many tools available on the internet that can help you with GIS, or you can always ask me questions. To use the Multidimension tools, you must have the ability to access ArcGIS version 10.2 or later. My version is 10.6, so it might slightly differ if you have a later version of GIS, but the foundation is still the same. In addition, most of the topics covered today will be available in our upcoming training manual on the use of GIS to analyze climate change data. I apologize it's not quite ready and to be posted online, but will be available soon under the RICCAR Regional Knowledge Hub under Knowledge Resources. When this becomes available online, it will be both available in Arabic and English. We will let participants know. I will be referring to this manual occasionally for reference for you to look up data at a later date. With that, let's go over NetCDF files. NetCDF is just a file to compress data and organize data. NetCDF stands for Network Common Data Form and is used for array-based data. It is designated with an NC suffix. NetCDF files are commonly used for climate, oceanography, air pollution, and other data sets. NetCDF files typically contain 1 or more variables, such as precipitation or temperature, and 2 or more dimensions, which may be latitude, longitude, and time. This is described again in our training manual, section 3.1. NetCDF has the advantage that it's compatible with several applications. I've listed some here. One is Panoply, which is developed by NASA and is open access. The ability of Panoply is quite limited, but it does allow for some visualization of data, but it does not allow data analysis. There is also Python, which you can use to program for those who are familiar with Python. It is also can be used by the software program R, the statistics software. It can be used by MATLAB. It can be used by climate data operators, which is quite functional because it contains the ability of more than 350 operators, including the calculation of extreme climate indices and statistical analysis. You can read more about climate data operators, or CDO, at the link shown, as well as ArcMap GIS, of course, which we'll be covering in this module. ArcGIS has several advantages in NetCDF, which is why we endorse usage of the software. For one, many of you are already familiar with ArcGIS. You may be already using it in your day-to-day work. ArcGIS has also the ability to visualize data. And thirdly, it allows for comparison of other geospatial data sets, such as shapefiles or rasters, which you can use for other comparative analysis. However, ArcMap GIS does have some limitations for NetCDF files. For example, it cannot clip data. If you have downloaded the data set we are using today, you will find that it is an extracted data set. I had to extract this data set using CDO operators, which I mentioned earlier. So, for certain purposes, you may need to use other softwares. And as mentioned, ArcMap GIS cannot perform statistical analysis. It cannot calculate indices, extreme climate indices, and other limited functions. ArcMap GIS is also not compatible with all NetCDF files. They must be in NetCDF4 format, which luckily is the current standard, and most climate data sets available today, as well as the RICCAR data files, are in NetCDF format. And they also must have geospatial data included, which again is applicable for the RICCAR data as well as other climate data sets, to have the ability to have georeferencing in terms of latitude and longitude. With that, let me go over what are NetCDF files. During last week's module, we presented maps of our outputs. These maps were representative of included precipitation and data sets representing an ensemble mean of 3 or more, and in this case were 3, climate driving GCMs, which were EC Earth, CNRM CM5, and GFDL ESM2M, and it was averaged for a mean over a 20-year period, such as mid-century, which is 2046 to 2065. However, our entire library of NetCDF files is way beyond what was presented in this last week's maps. We have precipitation and temperature data, and temperature includes both daily average temperature as well as maximum and minimum temperature. It is available at daily resolution. It is bias corrected data, and it is available from 1951 to 2100. It is available at a 25 kilometer grid, or 0.22 degrees, or at a 0.44 degree grid, which is approximately equal to 50 kilometer, which is where the maps presented last week. We have multiple driving GCMs. Again, they were EC Earth, which is from from a European consortium. We have CNRM-CM5, which was developed by the National Center for Meteorological Research in France, and GFDL ESM2M, which was developed by the Geophysical Fluid Dynamics Laboratory located at NOAA in the United States. For the 50-kilometer data, we have data both at RCP 4.5, RCP 8.5, which are presented in our RICCAR main report and was presented last week, as well as RCP 2.6, but it's only available for EC Earth data. This data is available should you want to do analysis and some comparisons. However, unfortunately, RCP 2.6 is not a likely scenario, which is why we did not analyze it further. The 25-kilometer data is available for only EC Earth and GFDL ESM2M models. Because of this, because there are less than 3 members, we do not recommend developing an ensemble for these data sets. You can, however, do a comparative analysis using the 2 different GCMs. And this data set is only available for RCP 8.5, the more extreme or business as usual scenario. We'll be talking more about ensembles in a future webinar module. Some of the advantages of using the RICCAR RCM outputs. As mentioned last week, we have data for the entire Arab domain, and it is also known through the Cortex as the Cortex MENA domain. One of the participants during last week's module mentioned that Iraq is located in the Central Asian domain. While this is true, this domain does not include the entire Arab Peninsula. Instead, it only goes up to about as south as this, where I'm showing here. This is unfortunate, you know, if you want to compare to the entire Arab Peninsula or elsewhere within the Arab region. So our data sets allows for, it facilitates comparisons across the entire region. We also developed the domain to consider circulation patterns from the Indian Ocean, as well as transboundary shared waters that include our region, such as the Tigris-Euphrates, as well as the Nile basins. These assumptions are considered all the same, these boundary conditions from east to west and north to south across the Arab region. The second advantage of using our RICCAR RCM outputs is the fact that they are bias-corrected data sets. And what does this mean? First of all, again, our data sets run from 1951 all the way to 2100. Starting with the IPCC report, Fifth Assessment Report, data from the end of 2005 and earlier is known as the historical period. Starting from 2006 and moving forward are the RCP scenarios. For the bias correction, we took a reanalysis data based on the watch forcing data for ERA interim, which covered a period from 1980 to 2009 to facilitate coverage both over the historical period as well as the RCP scenarios. The reason why we do this is because models tend to have inherent weaknesses, such as areas that have heavier precipitation or areas that may have colder temperatures that are not expected in these areas. Bias correction minimizes these areas of weaknesses with actual data sets, actual observed data sets. It is noted that bias correction is a complex process and can be considered a bit controversial in the modeling realm. We do not connect bias correction here at ESCWA or the Arab Climate Change Center, and nor do we recommend our participants do so either. And we delegate this responsibility to our partners who conducted the modeling at SMHI. They use a method called distributed-based scaling, and more information can be found in the RICCAR main report on this, as well as a technical note on the modeling outputs, which are available again from the RICCAR Regional Knowledge Hub website. But it is noted that bias correction, although these bias corrected outputs can be debated, usage is becoming more and more widely accepted. Moreover, usage is recommended for hydrological studies, as well as impact studies, which like what was applied for RICCAR. The third advantage of using RICCAR RCM outputs is the fact that it is in Gregorian calendar format. And what does this mean? Well, the Gregorian calendar is the current international standard based on 365 days per year, with 366 days every 4 years, also known as leap year. Different climate modeling outputs may have different calendars. You may note that the GFDL model, GFDL ESM2M model, is typically based on a 365-day calendar. Every year, including leap years, only have 365 days. Our modeling outputs for RICCAR, even though we have GFDL models included, are based on the Gregorian calendar format. So you will have 366 days during leap years. Other climate models, such as the Hadley GEM2S model, which is developed by the Hadley Center in the UK, uses a 360-day calendar format. That means that every month, including February, has 30 days exactly, which can be a little complicated to use. The fourth advantage of using RICCAR climate modeling outputs is the fact that we include extreme climate indices. Here we have the temperature extreme climate indices listed. Typically, these indices are not readily available and must be calculated using other software such as Climate Data Operators or CDO. These indices are widely used and were developed by the expert team on climate change detection and indices. The exceptions are SU35 and SU40. The reason why, as discussed last week, is that SU, which is the commonly used index, bases summer days as temperatures over 25 degrees Celsius. However, for our region, most areas already exceed 25 degrees for most days of the year. This is why, for RICCAR, we introduced these new indices which raise that temperature threshold from 35 degrees to 35 degrees as well as to 40 degrees. Here are our precipitation extreme climate indices. These are particularly useful to assess flood and drought risk. If you look at our maps, you may find areas that may reveal projected decrease in precipitation. However, but the maximum length of wet spell, the CWD, is increasing. This suggests that overall rainfall is declining, but when rain events occur, they happen on consecutive days. Another example is increasing precipitation coupled with a greater increase in R10, or number of 10 millimeter precipitation days. This signals a general increase in rainfall, but they happen to occur during heavier rainfall events on particular days. Both of these examples can indicate increased flood risk for different reasons. The fifth advantage of using RICCAR modeling outputs is the fact that we use common units of measurement, such as degrees Celsius for temperature, millimeters per day for precipitation, and days per year for the indices. And then for SDDII, which is the simple precipitation intensity index, is in millimeters. Typically, if you look at other climate models, they use standard calculation units, such as Kelvin for temperature or kilograms per meter squared per second for precipitation. These units are not only counterintuitive, but they also require the additional step of conversion for presenting results. However, RICCAR does have some disadvantages, unfortunately. For one, the spatial and temporal resolution may be too coarse. Again, our data sets are generally daily, and for our ensembles, we use 50-kilometer data, which may be difficult to use if you are doing analyses in small hydrological basins. Some climate parameters are not evaluated, such as humidity and wind speed, which may be of use in certain applications. And lastly, which may be the biggest disadvantage, is areas along the coastline may be gapped, as seen here. The reason for this is during the bias correction, grid pixel squares, of which over 50% covered a water body, were eliminated. We hope that many of these disadvantages will be resolved with our forthcoming MeshRec domain, which was described last week during the module. The MeshRec dataset will, even though it is called the MeshRec domain, it will go beyond the MeshRec area to include the entire Arabian Peninsula, as well as Eastern Egypt and Sudan. It will be available at a 10-kilometer scale and will include other climate parameters beyond precipitation and temperature to include wind speed and humidity. If you happen to have other data needs that are not met by RICCAR, we will discuss how to obtain data from Cordex or other climate data sets in Module 5. The RICCAR NetCDF file names are quite long, and for those of you who have downloaded data from our events webpage, you may have had some difficulty, and I'd apologize for that. So please let us know if you had some difficulty and we will help you. But I wanted to keep the entire name to keep consistent with what is shown here, which are our original files. This file name happens to be for precipitation, which is indicated by the climate parameter PR. It shows that it is the MENA Cordex domain at 0.44 degree resolution. The next is the entire name of the driving GCM, CNRM5 is the short name, developed by these two research institutes. Next is the climate scenario, which shows historical and RCP 4.5. As I mentioned, for the bias correction data that was used for the observations covered both the historical period as well as the RCP scenarios. Because of this, it is important to use the appropriate historical period according to the RCP. So thus, you will use historical RCP 4.5 data for if you're using historical data in that regard, and likewise for RCP 8.5. The next designation in the file name is the ensemble member designation, which may not be significant for most of you, but does tell a lot about the modeling. R is for realization or model starting point. I is for initialization, and P is for physics. So if you really want to get into climate modeling, this may be of interest to you. The next set of information is the regional climate model used as well as the agency. Again, our modeling was conducted by SMHI, who are the Swedish Meteorological and Hydrological Institute. And they use their model, which is the RCA4 model, which stands for Rossby Center Atmospheric Model 4. For the bias correction, they used distribution-based scaling. The next information represents the temporal resolution, which in this case is daily. The next is the time period. So the data set covers from January 1st of 1951 to the 31st of December 2100. Please note that for EC Earth data RCP 8.5, the data actually begins in 1970. Although this is the case, it will still show this entire data set period. So that may be a word of caution that sometimes creates confusion for some people. So just bear that in mind. Next, we'll show the time period for this particular file, which is 2046. And lastly, again, for NetCDF files, it has a suffix of NC. A similar naming convention is used for the extreme climate indices. One thing to note here is the temporal resolution of this data set. This data set happens to be an annual data set, which would mean days per year, which is designated by ANN. Other data sets available may be seasonal and are defined by 3-month seasons, such as December, January, February, March, April, May, June, July, August, and September, October, November. This naming convention is standard for Cortex datasets. If you happen to download data for Cortex, you will find similar naming conventions, which will, again, it will tell you a lot about the datasets. One thing to note is the abbreviation in the NetCDF file may not immediately be apparent. TAS is for near surface air temperature, and likewise TAS max is for daily maximum near surface air temperature. TASMIN is for daily minimum temperature. And it is important to note for the R10 index, the count of 10 millimeter precipitation days, and the R20 index, the count of 20 millimeter precipitation days. Although we refer to these data sets as R10 and R20, the abbreviation shown in the NetCDF file is PR10 and PR20. That concludes our first half of the webinar covering NetCDF files. We'll take a moment for a quick break before we will start using the files in ArcMap GIS. All right, so we will start working in ArcMap GIS. Again, I'm using a version of ArcMap 10.6. You will need versions 10.2 or later to conduct the exercises. I apologize for the webinar format because in the past we have done these types of workshops live and with an interactive experience, and I've conducted these workshops with Oxad, who is one of our RICCAR partners. And that allows for us to conduct the exercises in person and working out issues you may encounter. But the advantage of doing this via webinar is we are able to reach a much wider audience. We have participants today from all across the Arab region, as well as in Europe, such as Germany, UK, Spain, and Portugal. We have a couple of participants from North America, such as the US, from South America. So we thank you for your enthusiastic participation. For those of you who want to, you may wish to follow along these exercises using ArcMap GIS yourself during this webinar module, but otherwise you can work on the exercises after the conclusion of this webinar, and you may feel free to ask me questions at any time. So when we use ArcMap GIS, we typically add shapefiles and rasters using this plus icon here. You cannot do this for NetCDF files. Instead, we must use a tool called a series of tools known as the Multidimension tools. And these are only available in versions 10.2 or later. You have two options to open the multidimension tools, depending on your own personal preference. You may search for the tool using the search icon and typing in the multidimension tools. Or you may open up the Arc toolbox using this icon to select the tools. Either or, they both get you to the same location. It is just your own personal preference. When you open up the multidimension tools and expand the tools, you will see several tools available. Here I am showing it on the English version, the Arabic version, and lastly the French version, for those of you who may have different language versions of ArcMap GIS. During this webinar module series, we will be covering two different tools. One is the Make NetCDF raster layer, and the other is Make NetCDF table view. Today we will focus solely on NetCDF raster layer, and next week we will focus on the Make NetCDF table view. When you open up the Make NetCDF raster layer, it will look something like this, and this is for the English version. Here is the tool in Arabic, and the information panels are in the same order. So if you are using other versions of GIS, it will follow the same order I will be discussing today as is for the English version. And thirdly, here is the tool in French. First, we will select the NetCDF file using the folder icon here. You will have an opportunity to select any NetCDF file. In my folder, I have all of the NetCDF files available. And for the exercise, you may have one only, and make sure you extract it from the location where you have saved it on your own computer. Later on, if you happen to download data either from the Regional Knowledge Hub or I've provided to the NetCDF files directly, you too will have NetCDF files, all of the NetCDF files. So you'll first select the NetCDF file that you will need to create the raster layer. It will automatically populate with the file name. It may be an abbreviated version like what you have seen on my screen. And these next four options will be automatically populated with default names. You will need to change these defaults or else your NetCDF file, raster file will not work, or it might be geo-referenced inappropriately. The first option is the variable. And in this case, we select PR for precipitation. Next, we select the X and Y dimensions. By default, N long will show and N lat will show. You must change these to long for longitude and lat for latitude, or else your raster file will be geo-referenced incorrectly. This next option is the naming of the output raster layer. You can leave the default name as I've shown here, or you can change it to a user-defined name. You may want to define it as PR_2046 to have the year indicated, particularly when you start creating multiple raster layers. These remaining options are all optional and are actually recommended to remain blank for now. The band dimension is for NetCDF files which may have other data sets included. For example, it may include elevation data. This is not applicable for RICCAR data and other climate data sets, but there are some that are, some data sets that may be available out there. So the result, if we were to select elevation here, it would only show the NetCDF raster layers based on a single elevation. For the band dimension, for the dimension values, you can select time here with an appropriate value. This is an option, but for now we will leave it blank. And the last panel is the value selection method. The default is by value. By value means that the input value is matched with the actual dimension value, which is applicable for climate data. So we will leave the default. The by index option means that the input value is matched with position or index of a dimension value starting at 0. For those of you who may be using later versions of ArcMap GIS, you may also have cell registration shown here at the bottom. Center cell registration is the default. Once all data is entered, you can select OK. The result will look something like this. And I happened here to show you the result for if we were to use the entire Arab domain data set. So you could have a sense of what it would look like. The color scheme that is shown is default and may be different if you're using another version of GIS, particularly the Arabic version. If we look at the table of contents, we will see precipitation values that range from 0, which are shown in blue, to 141.31 for areas in red. Because our data set is in daily resolution, the precipitation values are millimeters per day. If our NetCDF file happened to be monthly data, this result would be in millimeters per month. If you want to use the entire NetCDF file, you can do so. If other than the one that is posted to our events page, they are available from our RICCAR Regional Knowledge Hub using the data portal, which you click on here. But I caution you, not all NetCDF files are there quite yet, particularly the temperature and precipitation data. But we do at this time have the extreme climate indices, most of them, if not all. Otherwise, you may request them from me directly, and I will be happy to provide them to you. A word of caution, though, the entire NetCDF file, each NetCDF file is about 40 megabytes in size. And to avoid huge downloads, this is why I extracted a data set based on Morocco to avoid huge downloads. So if you were to see the results from Morocco, you would see and create and make NetCDF raster, you could see it here. And I included the Arab domain shapefile so you could have a sense of geographic reference. The range of values happen to be 0 here. And don't worry, I'll explain why in a minute. Morocco does have precipitation. NetCDF files contain multiple time slices. So each of the temperature and precipitation files have 365 time slices, one for each year, and for leap years we'll have 366 time slices. Extreme climate indices have 150 time slices, one for each year from 1951 to 2100. So by default, the first time slice, which is shown, we create the raster layer, is January 1st for precipitation and temperature data, and 1951 for the extreme climate indices. So thus, if we were to look at, again, at our entire Arab domain, this result is just for January 1st of 2046. And similarly, for Morocco, this result is just for January 1st of 2046. We can right-click on the layer name in the table of contents to display the layer properties. When you do so, you will find the layer properties with several tabs, including the NetCDF tab. It will show your variable, your X and Y dimensions, as well as a band dimension if applicable, and you will say the time dimension is January 1st of 2046, which is currently shown in the display. Here it is shown for the Arabic version, and here it is shown for the French version. We can select different time slices using the drop-down box. I have found that other ArcMap versions may show it differently. Mine happens to be showing the date in month, day, year format, and followed by the time, which happens to be negligible because the resolution of the data set is daily, so the time is irrelevant, but it still happens to show. Your GIS version may show day, month, year, or you may not be able to use the drop-down box at all and may have to enter the date manually. That's okay, and it may require some trial and error, but and if you have any questions, again, feel free to ask. So if we were to select a different date, the raster layer will adjust accordingly. And this layer happens to be a range of 0 millimeters per day to 49.58 millimeters per day, which happens to be for the 10th of June, 2046. Note that these raster layers are only in the computer temporary memory. So if you were to shut down ArcMap, it will be erased and will not be saved. You can save the raster layers by using Save as Raster Layer for exporting data, or you may export as a raster, as shown here. The second option will only export the current raster shown, however. There is a way to extract multiple time slices automated by a tool created by Esri and ArcMap, which will automatically extract every time slice from a raster file. The instructions and the tool are freely available at the link shown. This is also discussed in the RICCAR training manual section 3.2.2, and we will use this tool when we for module 4 when we discuss creating ensembles. Lastly, if you are interested, you can use the ArcMap model builder to automatically extract multiple rasters based on a specified shapefile, such as a specified area, such as a shapefile. This is discussed in our forthcoming training manual on the use of GIS to analyze climate change data in section 3.2.3. And with that, I thank you very much for your participation. If you have any questions about the exercise or the data or GIS, please feel free to contact me. Here is my contact information. It is also shown on the information flyer. And with that, I will ask Joelle to relay any questions to answer during our remaining time. Thank you. Joelle?
Yes, Marlene, we have a few questions. So the first one concerns the ERA interim reanalysis data. So someone is asking that this data has systemic errors, as it is mentioned in various publications. So do you have a collection of observation directly from countries to produce more accurate baseline representations? There was also a similar question for the climate parameters. Are you relying on local records or just on these global data sets?
Unfortunately, because we need to use a data set that entails the entire Arab region consistently. As you know, much of the region is unpopulated and thus does not have meteorological stations, which is why the modelers at SMHI elected to use a real analysis data set. But I encourage you certainly, if you, during your research, you can do comparisons if you elect to do so. It may be an interesting note of interest. Our data sets are based on models. They are not based on trends. They are not based on observation. They are based on strictly on models. So our results are downscaled from global climate models, the 3 global climate models I showed earlier. And so there is no consideration of observations accordingly, because that's not the methodology that was utilized. Thank you.
Okay, there's another question concerning slide 16, where it shows that there are data gaps generated due to the bias correction. So a participant is asking, how can bias correction can generate data gaps? If you can elaborate a bit on this. Again,
most of our data includes the entire AORB region. This area happens to be gapped. It is only gapped in certain areas, like, in selected coastal regions. And these areas were gapped because we used the reanalysis data set, the WATCH data set, and which does not quite reach to the coast in all cases. So if you happen to need data for this particular location, I encourage you to look at the surrounding pixels and average data for the surrounding pixels for your analysis. So again, I admit this is a weakness, and we hope this will be corrected and for our forthcoming mesh-rec domain data set. And again, if you need, there are other bias-corrected data sets, notably for the European domain, which we will discuss in, I believe, Module 5. And this European domain will only reach just in North Africa, as well as the Levantine coast. But there is bias-corrected data there available, and it will cover coastal areas. So again, that is a weakness, but we're hoping to resolve that for our forthcoming mesh-rec domain. Thank you.
There's another question on historical data and whether it can be used to calibrate hydrological models, and if GCMs share the same historical data, if all GCMs share the same historical data.
Yes, indeed. The historical data is based on the models themselves. I do recommend using the historical data for if you want to compare them to projections, the modeling projections, because it is based on the same assumptions and methodologies. If you just want to look at historical trends, if you're doing hydrological modeling, I would recommend that you use observed data sets, which you may have available, which may be more accurate. So it depends on your intent of your study.
Okay, another question. Can you download daily or monthly time series?
No, well, we can. I will show you that in a future webinar, and we will just be discussing time series data next week.
Okay, another question. If it's possible to upload NetCDF files to GIS?
This is what I'm not quite clear on this question.
Okay.
So if the person can clarify, please.
Okay.
We discussed how to use NetCDF in a GIS format during this webinar, so I'm not quite clear on this question.
Okay, next question. Are there any variables for sea surface temperature?
Unfortunately, no. These are land-based models, so they only cover the continent themselves. But there are other data sets which, to some extent, includes sea surface temperature. We will discuss accessing other data sets during Module 5.
Okay, we have another question on the results for Morocco. Participant is asking why the results in Morocco show a 0 value for minimum and maximum?
The reason for this, let me go back to this map, is this is only showing one time slice. If you remember, when we create a NetCDF raster layer, it will by default show the first time slice in the file. So this happens to be the result that for January 1st of 2046. If we were to look at other time slices, these values will change accordingly. And they will, have a range. So it just happens to be for this particular default time slice is the values are 0.
Okay. We have another question about the data. When there are two different RCPs, the historical data seems to be different. So if you can clarify on this point.
Again, if I go back to the bias correction, we see that the reanalysis data set covers from 1980 to 2009. And the reason for this is to cover both the historical period and as well as the RCP scenarios. So when we hindcast, the historical data set will very, very slightly differ for the historical periods, whether it be an RCP 4.5 scenario or an RCP 8.5 scenario. Because of these slight differentiations, I suggest you use the appropriate appropriate file corresponding to the RCP scenario you are analyzing. And with that, we will conclude for today. I thank you for your attention and participation. And again, always feel free to contact me if you have any questions, and I'll be happy to help. We look forward to you joining us next week for Module 3. Thank you.